Hi, my name is Fox. I'm going to take you through introduction of pneumatics in the section of pneumatics and hydraulics in automation workshop. What is pneumatics? Pneumatics is the science and technology of pressurized air using piped, compressed air to transmit force and energy. So basically we use compressed air to drive mechanical workpiece. Remember guys, energy cannot be created or destroyed, but it moves from one form to another. So for us to have the mechanical movement or mechanical motion, we use compressed air. Pneumatic is used in industries for the performance of mechanical works, and it is also used in the development of automation solution. Just like hydraulics systems. But the difference between pneumatic system and hydraulic system is that pneumatic use compressed air, whereas hydraulics uses liquid. In general, on the picture that you see below, uh, I have a picture of I have a picture of I wanna bring a pen and a highlighter. I have a picture of our daily use of pneumatic system. Uh, we use pneumatics almost every day, but some of us we don't know that we are using pneumatics. If you are pumping your ball, you wanna play soccer, there is pneumatics involved because there is compressed air that you are using. For you to pump your tires, it's pneumatics. Train doors, they use pneumatic to open. The jackhammer uses pneumatics. Okay, just like any other system, you must have input, process, and output. Also with the pneumatic system. In the pneumatic system, we have sensors which act as our input into our system. We have control valves which will process the information that the sensor will bring, and we have the switching elements or the switching valves which will execute decision in deciding what actuator should do. Actuators are the output, are the one that's gonna give us the the motion or the physical work. So sensors will be our input, processors and switching valves will be our process, and actuators will be our output of our pneumatic system. Okay, so when we are working with pneumatics, there are advantages and there are disadvantages. In a pneumatic system, we have advantages that pneumatic has unlimited supply of air. Like we take air from the atmosphere, we compress it in a reserve tank, and we use it to do the work. So we will never reach a point where we'll say we have run out of air because we take the atmospheric pressure that we breathe. So air is just there for free and it is unlimited. So that's one thing that is nice about pneumatics, that we have the unlimited supply of air. And the pneumatic system, it is easy to transport and release air. Let's say we've compressed the air, we are using it to drive our cylinders. When we are done, we can then take that air back to the atmosphere without any problem. And the pneumatic component, they are so strong and they last because of the applications. and the limited or the limits of pressure that they can withstand, they are so strong, like it's one of the best components. Pneumatic system, they they're adaptive to harsh environment, and they're applicable into hazardous environment where intrinsic safe is a major, like in explosive plants. Since pneumatics does not cause any spark, it can work so nice and it can do the job without any risk or potential hazard. And the pneumatic system are environmental friendly since they don't produce any pollutants. But there are bad sides of pneumatics. The bad side of pneumatic will be it makes a lot of noise. Processing is required before you can use pressurized air in your pneumatic system. Like you must filter that air, you must regulate it, you must lubricate it if need be. So before you can use pressurized air, it must be processed first so that it will be clean and it will be on good standard for your system. Compressed air can leak easily, which may cause loss of energy. But nevertheless, when we are working with pneumatics, there are safety procedures that we must adhere to. First thing first, when we go to the pneumatic section in the workshop, you can't work without the proper PPE. The PPE that is required for you to work in that section is safety goggles, earplugs, and safety boots. Since we know that anything can happen, so it's best that if something falls from your workbench, your foot is protected against any potential hazard or harm. And since we know that pneumatics produce excessive noise, we must put on our earplugs. According to safety, if your working environment produces noise that is above 83 decibels, that environment is no longer safe for your ear, so you must use earplugs. So we've tested pneumatic and it produced about 130 something decibels whenever you open a pneumatic valve under pressure. And for your eye protection, you must wear your safety goggles. When you are working with pneumatic, in that section you are not allowed to exceed the limit pressure of 600 kilopascals. In the next slide, I'm gonna explain when I'm talking about compressor why you shouldn't exceed 600 kilopascal, of which is 6 bar. You should not switch on the compressor until you have perfectly connected all your tubes. Because if you apply pressure in your system and some of the tubes are not rightfully connected, that may cause harm to you or to the people next to you. So for your safety and the safety of other people, before you apply pressure, make it a point that you check if all pipes are connected and they are rightfully fully connected. And whenever you are done with your system, you should never try to disconnect a line when your system is still under pressure. Particular care is to be taken when switching on compressed air. Cylinder may advance or retract as soon as the compressed air is switched on. So before you switch on, make it a point that you clear all spaces or you move away from the cylinders, because the piston rod of a cylinder may advance any time if you apply pressure on your system, of which might cause harm if you are not cautious. Compressed air is dangerous. So guys, do not use the compressed air for any other reason beside the reason which is provided for. Never direct the stream of compressed air toward your body or the body of another person. Do not use compressed air to cool yourself or to blow dust from your clothes or to blow your hair or even clean the workbench with compressed air. You should not do that, guys. Okay, so we're going to talk about pneumatic components. We have supply elements, we have input elements, we have processing elements, and we have power components. In the supply elements, we will find things like compressor, because compressor is the source of our pressurized air, since pneumatics works with pressurized air. Input element are the sensors, things like push buttons, your limit sensors. We're going to touch on those as we progress with the lesson. We have processing elements, valves. The valves that receive signal from input elements to execute decision to what should your power component do. Your control element, your processing elements are connected to your power component. They're the one that makes decision if your cylinder will advance or your cylinder will retract. Okay. In the supply elements, we have compressors, air service units, and gauge. What is a compressor? What do we use compressor for? We use compressor to supply air pressure to the system. As a rule, pneumatic components are designed for a maximum operating pressure of 8 to 10 bar, of which is 800 to 1000 kilopascals. But in practice, it is recommended to operate between 5 to 6 bar for economic use and for safety precaution. Due to pressure loss in the distribution system, the compressor should deliver between 6.5 to 7 bar to attain these figures. So, here I have an ISO sign or symbol for a compressor. I have a mobile compressor here, and I have other compressors there. For those who've never seen the compressor, when we go back to the workshop, I'm going to take you to the compressor, and I'm going to show you also the mobile compressors that we have in the workshop. We have a service unit connected right after the compressor. The function of a service unit is it is used to clean pressurized air before the pressure gets into the system to ensure the quality of the air in the system. It consists of 3 components, of which is a filter, air filter, which is situated here. Let me bring a pointer, a laser. Situated here. It has a regulator. This is the regulator where you'll set your pressure to your system. Let's say you want only 4 bar to your system. This is where you will regulate. And here it's where you will lubricate your pressurized air. Why do we use lubrication? To reduce friction uh, to our to other pneumatic components. So this is the sign for your air service unit. You can either use this sign or you can use this one. We also have pressure gauge. A pressure gauge is an instrument used to measure pressure. The pressure gauge is connected to a specific point to measure or display the amount of pressure where it is required. Let me remind you of SI units of pressure. Pressure is measured in pascals. You will see other pressure gauge will have a reading of PSI. PSI stands for pounds per square inch. 100 kilopascals is equivalent to 1 bar. 1 kilopascal is equivalent to 0.145 psi. 1 psi is equal to 6.897 kilopascal. 1 bar is equal to 14.5 psi. Why these conversions are important? Because other gauge you'll see, just like the gauge that I have here, it has both display of pressure in bars and in psi. We then move to power elements. Power elements, we have actuators. An actuator is a device that converts some type of stored energy into motion. The stored energy is usually in a form of compressed air, electrical potential, liquid pressure. It is typically stored within the sealed cylinder made in most cases from metal. The actuators are complemented by control elements which transfer required quantity of air to drive the actuator. Normally this valve will be directly connected to the main supply and fitted close to the actuator to minimize losses due to resistance. We have two types of cylinders. We have a double acting cylinder, we have a single acting cylinder. With a single acting cylinder, it has a spring inside. This is the sign of a single acting cylinder. As you apply pressure on this pot, the pressure builds up here, which pushes the piston rod to make the cylinder to advance. As this piston rod advances, if you cut that pressure, it will immediately go back to its initial state because of the spring. As you apply pressure here, you compress the spring. As you compress the spring, when you stop supplying pressure here, the spring will take the cylinder to its initial position. And we also have a double acting cylinder. A double acting cylinder is different from a single acting cylinder, that for it to retract, you need to apply pressure on the other port. It consists of two ports. For it to retract, you must apply pressure on the other port, then it will retract. We have input elements. Remember, input elements, they are our sensors to our system. They determine the state of the processors. So here I have a proximity limit switch. This is attached. This switch is attached to the cylinder or to the actuator, and it works as a sensor to detect if your cylinder is fully advanced or fully retracted. It has a magnet inside that detects whenever the rod of the cylinder inside inside your actuator, if it's fully advanced or fully retract or halfly advanced. We have another sensor that does the same job, of which is roller lever valve. Roller lever is a mechanical operated valve that uses mechanical position sensing in machine automation system. It is used to detect the position of the actuator. As the cylinder advances, the piston rod will push the roller lever down. As it pushes down, the roller lever opens and allow pressure to flow between port 1 and port 2. You should never forget that in port 1 is where we'll always supply your component. But I'm going to touch on it when we move to directional valve. We have a control element. A control element is a component that is used to redirect the flow of pressurized air from one component to the other one in a pneumatic system in order to control the final control element, of which is the actuator. Pneumatic valves are one of an array of components responsible for controlling pressure, rate, amount of air as it moves through the pneumatic system. The valve can be either mechanical operated or pneumatical operated. I have a flow control valve, of which we use it to control the speed of a cylinder. The flow control valve is used to regulate the flow of pressure in the tube. By doing so, the speed of the actuator can be controlled to the desired value. So what happens here, I'm going to show you in a short clip what really happens when you are using this control valve. Let's take a look. So as pressure moves forward,
the color and the low pressure return flow is shown with. By changing the needle position, we can change the flow rate going toward the cylinder. This way the forward speed of the piston of a cylinder can be fine-tuned. On the other hand, the reverse flow goes over the check valve and needle valve combinations. This prevents the fine-tuning of the return flow, since we do not have any control over the flow passing through the check valve openings.
So guys, this is the sign for the flow control valve. It has a throttle and it has a check valve. If you apply pressure from this side going this side, and look at the throttle, the arrow that it points towards your right direction. So it regulates the flow of air that is going forward. Because whenever the pressure tries to take this route, it is blocked in a check valve. Check valve only allow pressure to flow in one direction. So as it passes through the throttle, then you can regulate the amount of pressure that you want to flow. So wherever the arrow is pointing, wherever the arrow of the throttle is pointing, that's where your flow control valve will control or regulate the pressure. But in the other direction, it is not regulated. For instance, if you're applying pressure from bottom going up, the pressure that you apply here is the pressure you're going to get here, because it is unregulated. It goes through the throttle, it finds resistance, it comes this side, it's an open way because it will push the ball and the ball will open, then it will pass through. But if you are applying pressure from the top going down, the pressure will try to take this route, and this route is blocked. Then it will come to this route. When it comes to this route, there is a regulator here. Then you can then regulate your flow of air. We have directional control valves. The directional control valves can be push buttons, switches, or roller valve, and they are mechanical operated. The directional control valve is represented by the number of control connections, the number of position, and the flow path. In order to avoid faulty connections, all inputs and outputs of the valve are identified. So, how do you interpret the valve? The first number of the valve will represent the number of ports. What do I mean about ports? Is where you will connect your pipe, or it's the pathway where pressure will flow. And the second number represents the number of positions. What are positions? These squares, this square and this square, those are the positions. Let me draw it. So let's say this will be position 1 and this will be position 2. Then let's say I will have 1 and I will have 1. Ne? Let's say I will have 1. So this will be my port 2, this will be my port 1, this will be my port 3. Remember, we will always supply your component at port 1. So position 1, position 1 and position 2. When you operate your valve, it will change the positions. Let me show you in a small clip that I have here. Let us watch.
Boxes in the figure specifies the number of valve operating positions. So if we have 5 boxes, we have 5 positions, etc. Here we have 3 boxes, so it's a 3-position valve, a 3-position control valve is been represented. And now you can see the pipe works towards the control valve. The pipe works are normally represented in connection with the box which represents unoperated condition. So here the unoperated condition is the position 2, where we have all the ports will be blocked. Let's see it. So hydraulic circuits are normally represented in the operated conditions. So this is the unoperated position, which is the position 2, and those are the pipe works there, right? Now as we are clear about the positions, let's learn So let's see the ports. So those are the ports in position 2, and you can see all the ports are blocked. Port 1, 2, 3, and 4. So we have 4 ports in a single position. So let's see, in every position we have 4 ports each. You can count it, 1, 2, 3, 4. In each position we have 4 ports in each position, and these arrow marks show the direction of flow. Position 1, position 2, and the position 3. So it is a 3 position 4 port valve. You can count the positions down. It is 1, 2, 3. So we have 3 positions here, and we have 4 ports in each position. So it's a 3 position 4 port valve, and that's how the name of the control valve is derived, or how we represent a control valve in a schematic representation. Now let's see how this valve operates. Uh, there is no flow at the current position. That means at the center, the position 2, there is no flow because all the ports are in blocked condition. You can see there is no flow happening because it's in blocked condition. You can see the red color because it is getting pressurized because there is no flow happening. Then what happens when position 1 aligns with the pipe? So let's move. That's the position 1. When it aligns, you can see there is a chance of flow because the pipe is connected. There's a flow happening in both the directions, and you can see that's how the position 1 of the control valve get aligned and the flow is happening. And the same way what happens when position 3 aligns with the pipe. Let's see that. That's position 3, and when it gets aligned, the flow is getting reversed. So that's how it works. So that's what is position 3 is doing. So we believe you enjoyed learning it. You understand how a 3 position 4 port valve works, and how does the schematic representation of a
Okay, guys. So we have seen how the position and the ports work. Let me erase my drawings. Let's move to process elements. Process element. We have a pneumatical operated valve, this one. As a processing element, the directional control valve redirects or cancels the signal depending on the input received. So, at port 12, there I will receive a pneumatic signal. Whenever this valve receives a pneumatic signal, then it will change its positions from this position to this position. We have non-return valves. Non-return valves or check valve is the basis of the development of many combined components. There are 2 main configurations for non-return valves, with and without spring return. In order to release flow, the pressure force on the spring return design must be greater than the force of the spring. Let me start with this check valve. This check valve only allows pressure in one direction, guys. It will only allow pressure to move in this direction. Because whenever pressure tries to move in this direction, it is blocked, as you can see the ball. So as this one. What's nice with this one is that when the pressure applied is lower than the force of the spring, nothing will happen. But whenever the applied pressure is above the force of the spring, then it will allow pressure to move in this direction. Then whenever you cut pressure this side, spring will immediately close the valve. Okay. Then we have quick exhaustion. Quick exhaust valve. Quick exhaust valve allow pressure to flow in one direction. This is very, very good or vital for a single acting cylinder. Whenever the pressure that was built on the single acting cylinder must be exhausted. So it will allow pressure to flow up It will come in here, push the ball to this side, go up. But whenever we no longer have pressure here, immediately pressure will come from top, and here it will be blocked, then it will be exhaust back to the atmosphere without any problem. Okay. Then this other side, on this other side, we have a shuttle valve. The pneumatic shuttle valve and dual pressure valve have logic functions. Both have 2 input and 1 output each. The shuttle valve has the characteristics of an OR function, whereby at least 2 input, 1 and 1, are required to generate an output at port 2 of the valve. And in the case of dual valve, the characteristic is of an AND, whereby both 1 and 1 are required to initiate an output 2. If you know digits, for you to get a high on an OR, you must have an high on either side. So as with a shuttle valve, if you allow pressure on either side, you'll have pressure on the output port. But with a dual pressure valve, you must have pressure in both sides for you to have pressure coming out. All right. So we have 2 types of pneumatic controls. We have a direct control of a pneumatic cylinder, and we have an indirect. So with a direct is the simplest level of control for a single or acting cylinder. Involves direct control signal. With this type, with this type of a control, the cylinder is actuated directly via manual or mechanical actuated valve without any intermediate switch of additional directional control valves. So with a direct, we don't have anything. We connect our valve straight to the cylinder without any intermediate or anything in between. And it is good for application whereby we will have cylinders of small diameter. It is actually safe for small diameter, but if we are using larger diameters, it is not advisable to use a direct. So here I have an example of a direct control of a single acting cylinder. So here is the problem statement. A double acting cylinder of 25 millimeter diameter is to clamp a component when a push button is pressed. As long as the push button is activated, the cylinder is to remain in clamp position. If the push button is released, the clamp is to retract. So since we are working with small diameter, then it's simple. You just need a push button and a single acting cylinder. Here I have a compressor. As I press here, this push button will change the position. Then it will allow pressure to pass through. As the pressure passes through, my cylinder will advance, as you can see on this schematic. But we have another type of control, of which is called indirect control. With this one, cylinder with a large piston diameter have a high air requirement. A control element with high nominal flow rate must be used to actuate this. If the force should prove too high for a manual actuation, the valve then an indirect actuation should be constructed whereby a signal generated via a secondary small valve which will provide the force necessary for the control element. For example, same example, but the different piston size. A single acting cylinder with a large piston diameter is used to clamp a workpiece following actuation of a push button. The cylinder is to retract after the push button is released. Okay, so whenever I press the push button, it will change the position, then send signal. You see, send signal to a control element valve, which will receive signal and then change the state. Look at this. This push button has a supply element. Also, this has its own supply element, which may produce a huge amount of pressure that is required by this cylinder to advance. I hope you guys see the difference. But if you don't see the difference, please send me, text me on the group. We will break it down nicely. But before we can finish, I would like to show you the software we will be using to simulate all our project before we can connect it. It is called FluidSim. It is a software that is produced by Festo. I'm currently using a student version of which you can get it also. I'm gonna share a link. Student version is for free. You can download it at home and you can try it in the meantime. I'm just gonna show you how to use it. Okay, so on this side, that's where we will have your components. You will have your pneumatic components, you'll have your electrical components. All right, so let's say I want to build a direct control of a single acting cylinder. You press and grab, then you drop on your project site. Remember, the sign of the compressor is this one, the sign of the air service unit is this one or this one. Let me take this one, then I connect my air service unit. Then I'll use this as my emergency stop. If anything happens to my system, I must be able to press emergency stop. It is always advisable to have emergency stop. Then I will use a 3-2-way valve. Okay, I connect, I align it nicely, I also connect, then I run the simulation. I release my emergency. Whenever I press, you see what happens to the position, guys. It changed from position 1 to position 2. Now pressure is flowing between 1 and 2. I hope you guys were able to see. Let me zoom it in so that you see what will happen. Whenever I press, you see the position now. It is blocked. 1 is blocked, and 2 and 3 there is exhaust. So whenever I operate the valve, it changed the position. Whenever I release, it goes back to its initial state. So guys, this is the software you're gonna be using. If you have questions, please send a message on the group. We will continue with the notes. Guys, be safe. Thank you for your time. Hope to see you soon. Thank you.